Okay, folks, introduction to cloud computing and big data / data engineering, part S. And this one is going to be focusing on sort of Gartner's or maybe general view of the future of cloud computing. And the explicit topics covered are here: Gartner's cloud computing hypecycle and its priority matrix, hyperscale computing, which sort of intrigues me because it's roughly what I do. Serverless, again, I mentioned the importance of this. Cloud native and microservices. So these last three are meant to be the cloud developments which will have the most important impact in the near future, three years time, that type of time frame. All right, we'll start this lesson with a couple of slides from Kleiner Perkins, Mary Meeker, describing how the power of computers is measured, say, in the first case by computing capability per dollar. Here's what you get for $1,000 of computer equipment as a function of time from the IBM tabulator or abacus or whatever it was initially, which was not very many calculations per second. And up here we're getting up to 10 giga operations per second. And this is 1900, and here we are 2020 or something. And we have here the corresponding graph for storage, either measured as price per gigabyte, dive the way down, or capacity of a single disk going up to some 10 terabytes today. And they're both showing these are plotted in a rather extreme scale. This one only doesn't go back to 1900, goes back to probably, it's a bit unfair. There's not much plotted in 1956. I don't know what this is here. Anyway, it's not much. It really starts around 1980 and goes to 2017. And it just is dramatic. I still remember when I used these floppy disks, and I built the first parallel computer in the world, and we fought hard. I remember working with the computer science people at Caltech, and we were designing this parallel computer, and they said, we want to force people to work in parallel. We'll give them 16 kilobytes of memory on every computer. That will force them to chop the problem up into really small parts. I said, no, I can't do a real problem without 128 kilobytes. That is kilobytes, not megabytes or gigabytes, kilobytes. And we did lots of good work with lots of nice papers with 128 kilobytes per node. So we've changed. It just has crept up on us. And as I say, we're now swimming in this collaborative, continuous computing environment generated by these changes. And the second slide is a slightly different type of increase. Here's the amount of the internet connection, now up to 50%. And over here we have the social media, 33%. They're both tracking each other at about the same slope. And presumably there may be some areas of the world where this will not happen for a long time, but it will be more. Effectively, we will live in a world where internet and social media are totally pervasive. So that's the world we're living in, and that's just going to keep on going. But the fact that internet is 50% says that the impact of the increase in the internet universal connection is capped at another factor of 2. So we can't get a lot more. We have to deal with it. So we can look at the people we have now to see what's exciting. Right. So this is, again, Internet Trends, which is looking at cloud evolution. And they sort of support the same trends you get from Gartner and listening to Amazon, namely containers and microservices are highlighted. Well, that's what we keep stressing. Software delivery, how you actually deliver capabilities to people. databases which are very flexible, namely they're distributed, very large, they support analytics, and they elastic, they grow in size. And here you have BigQuery, Redshift, and I must admit I do not know what Snowflake is. We can look that up. Edge computing is another one I've stressed many times. That actually does two things. It puts the source of data away from the cloud. It has the fog, which is away from the cloud, but the cloud is still critical. The cloud is the coordinating and ultimate source of infinite computing for the edge. Here we have the hype cycle for cloud computing. So let's see what we have here. We have serverless, not so far, blockchain, edge computing, hyperscale, digital business platform. Remember, we talked about digital business before. IoT platform, container management, function as a service, machine learning, software-defined anything. That's a pretty, cloud office, hybrid cloud, database platform as a service, so infrastructure as a service. Cloud computing is here. It's finally been located on the slope of enlightenment in the cloud computing hype cycle. But it's not too important enough now as an emerging technology to be on the emerging technology hype cycle. Actually, it's noticed these are different analysts. It was the fellow who did the emerging technologies, it's called Walker. They're published at essentially the same time, and I assume that Gartner's aware of possible inconsistency that cloud computing appears in one hype cycle on the slope of enlightenment and it's just disappeared. I think it's slightly irrelevant because the implication is the same. It's a mature technology. All right, priority matrix. Here we have cloud computing is transformational. That's what we like. Edge computing is transformational. Hybrid cloud computing is transformational. IoT platform. Machine learning. Platform as a service. Hyperscale computing, my favorite. And then we have here one which internal cloud service brokerage. That's putting brokers which make decisions for you inside the cloud. And an economy for APIs, namely that APIs generate a marketplace and a vigorous activity. Cloud Office, that's Office 365 extended. And here we have basic cloud capabilities, infrastructure as a service. Blockchain. It's interesting that blockchain is not viewed as moderate because it's so hyped. It's really hyped, blockchain, because it's partly connected to Bitcoin. But cloud management platforms, I would view those, maybe they're just so, I don't know why they're only moderate. They're pretty important. I said function as a service. I think function as a service is very important. And here's serverless. I would rate serverless and function as a service as more than moderately important. This is in container management. I would put that up there as more important. So I think they've slightly underestimated some of these core technologies which are establishing the ecosystems to support containers on clouds. I think that's going to have a lot of importance, whereas things like multi-cloud, which is putting lots of complicated clouds together, I don't think that's so important. That sort of will happen automatically just to make better use of infrastructure, but I don't think it will be as important as the ability to use serverless computing to really lower everybody's development time. So in this slide, I just give you three of the definitions. Hyperscale computing, which just to say is defined as computing at a massive scale, large, effectively implying larger scale than before. What an industrialized scale means, I'm not certain, because industrialization has a connotation of making everything very big and setting up giant organizations to do things. And this has to be done at all levels. The data center facility itself, the hardware, the system infrastructure, and the system software and the application software. Cloud service brokerage is a model where somebody acts as a broker to provide these cloud services. And that could be both public clouds and private cloud services. And this is the internal version of this is when that's all done internally to an organization. I don't think that's quite so exciting to me. I put this in here because I didn't know what cloud service brokerage meant. Cloud bursting is a well-known technology which there's a lot of research that's being done on, where the idea is to view the cloud as a backup, the Mother's Day backup. When your local facilities run out of resources, you just shift those jobs. There are jobs which aren't being processed to a back-end cloud. And though it's a perfectly reasonable way of getting elasticity without trying to change your basic infrastructure. So this is a good way to expand your work. You start off with a sort of fixed resource, your current internal cluster, and you add public clouds on demand when they're needed. Okay, here's yet another hypecycle. This hypecycle is for cloud computing. And it actually has even cloud computing on the hypecycle. Here it is. It's over here. Cloud computing. And actually, in some of these hypecycles, there's cloud computing, and in some they're not. It's sort of, even here, they're pretty near the plateau of productivity, and they're just halfway through the slope of enlightenment. And I think that's just in the eye of the beholder. Here we have classic cloud computing things, very near mature infrastructure as a service, software as a service, and so on. Platform as a service. These are all pretty mature, not so exciting. Here we have, what do we have? Blockchain, platform as a service, the software to enable blockchains. I'm not quite certain what site reliability engineering is. I can give you this reference to find it, but it's not so exciting. Here we have serverless, platform as a service. That's exciting. Software to enable platform as a service. Sorry, to enable serviceless and to allow people to program all these nifty microservices, a sand for it, where you have this sort of bunch of sand, which are all these microservices. They're just laying there, and every now and then you tickle it by sending it a message, and it wakes up and does its thing. That's the way you architect these computers. You try to build everything so that it can be, it's modular, no interference, and it can be built independently, so that when you have your software team, each member of the team only does one microservice. Up here we have giant computing, hyperscale. We have edge computing. We have container management. We have multiple clouds. We have IoT platform, the software to enable IoT. We still have machine learning on this one. Sometimes on some of these plots, machine learning is broken up into different things. Cloud native. How to write code so that they run well on clouds as opposed to running well on hippopotami or whatever else you use the program for. We have marketplaces for cloud, or networking for cloud, and then we have our favorite thing we've seen before, software-defined infrastructure. Hybrid cloud computing, how you run on your favorite old-fashioned university infrastructure, you burst to a cloud when you need it. Hybrid cloud computing. I'm not quite sure. I mean, hybrid cloud computing enables cloud bursting, which is a separate entry. So these are all fun stuff. Here is the same thing as priority matrix. Hyperscale computing, giant computing is still my favorite one in these areas. And it's 5 to 10 years. Transformational, and the only one of that. Edge computing is probably more important. Because it's really, I think this is not right. Edge computing is revolutionary and not quite clear how to do it. Hyperscale, it's clear how to do it. Hybrid cloud computing, that is clear how to do it. Machine learning, well, basic machine learning we know how to do, but it's so big, there's so many things that to do it properly is hard. Platform as a service is very important, and it probably isn't universally adopted, so it actually has a way to go. Whereas software as a service, actually putting an application on the cloud, is like cloud computing, transformational and essentially happening now. The API economy, the fact that you define your services to have interfaces, API's application interface is very, very important. And of course, down here we have all sorts of things with the word cloud in it. Private cloud computing, which I don't like very much, but it's basically declaring what you do at your local place of cloud, which you can do, but it's sort of in the eye of the beholder. And there's lots of little things here with fancy names, and I don't know why serverless platform as a service is not revolutionary. It's pretty important in my opinion. Anyway, some of these things at the top, I mean, these hype cycles are a little in the eye of the beholder in some cases, but the basic thrust is undeniable. Where we want to work on, we want to work on hybrid computing, machine learning, the various as a services, and we want to build these at the highest scale possible, and it must link to the edge. So that's where we are. Thank you very much. Now we can look and see how it compares. Okay, so this, as I rumored on the last slide, this slide compares 2017 to 2018, which are pretty similar because I've actually just done both of them. Cloud computing is sometimes in and sometimes out, and we have various transformational technologies in 2018, which have really seemed to have highlighted better than 2017 what's important. Deploying things as a service, edge computing, hybrid cloud computing, machine learning, building software that just enables other software to be written, platform as a service, and making everything support largest possible capabilities, hyperscale computing. That's where the actions are, and that's what you would use to build your continuous collaborated computing treacle, which will enable you everybody. Actually, it's not really treacle because it's making you run fast. So it's a wind. It's blowing you through the world, making your world better and better. Okay, that's the end of this particular section. Okay, here are some typical remarks and diagrams about serverless computing and function as a service. Here is a question: when I use Azure Cosmos DB or Amazon Kinesis, do I need to allocate a server for it or deploy a virtual machine? No, of course not. You just configure them from the portal and use them. That's the whole purpose of serverless. What happens if I want a simple function? Well, you just do it with serverless. If you want to run a function at every day at 2 p.m., you just set up an event to trigger it at 2 p.m. And you can set up events based on all sorts of things. A file being modified, a GitHub repository, or just any other, maybe an edge computing event being added to the event stream. And you can do these in various ways. You can have a VM and a container, and you run Kafka continuously, and it receives these events. Or you run Cosmos DB continuously, and it accepts these events. But then you pay even when they're idle, whereas you really would prefer to pay for just when it's used. And so serverless has this big advantage of being paid by the time used. And then we have these examples: Lambda, Azure Function. Lambda's, of course, from Amazon. Google Functions, IBM, Apache, OpenWhisk. IBM trying to catch up, donated their software to Apache. And then over here we have the evolution of data center computing, bare metal, virtual machines, containers, functions. These are the units of activity. And then over here we have some timing and effort estimates on premises, or data center, virtual machines in some like cloud, containers in the cloud, or serverless in the cloud. Time to make it initiated is week to months to buy new stuff for your data center, minutes to get a VM running, seconds to minutes for containers, milliseconds for serverless. The utilization correspondingly increases. Serverless packs, it being the smallest grain size, packs everything in. The charging is capital expenditure here for on-premises, and of course, VMs are charged by the hour, containers by the minutes, and serverless by the milliseconds. So that's pretty good, isn't it? Here's a slide I drew which sort of illustrates it. This comes from Alex Saminsky, the slide over here, which shows function as a service over here as a subset of event-driven computing, because the functions are invoked by events. And inside function as a service, we have these various implementations, which you mentioned, as well as the 3 commercial ones in OpenWhisk, which is sort of commercial as IBM, but also Apache. There is OpenLambda from Wisconsin. And then you could view peer-to-peer as serverless, because it's not using centralized services. And serverless overlaps with event-driven computing, which overlaps with function as a service. There was an old project called GridSolve from the grid computing days, which was essentially function as a service. If you go and buy this today, there's short-running stateless computation done in those functions, but I expect that to change. We already know it's meant to be cloud native. We know it's meant to be event-driven. We know it's meant to be very elastic, and it charges at the millisecond granularity. So these are just all the features of serverless function as a service. All right, here's some wise words from Gartner on serverless computing. And it's sort of interesting that they see this, they've said this before, that serverless will be supporting the use of computing outside the central organization, because serverless allows an individual to invoke their own servers. And this is rapid scalability, operational simplicity, on-demand pricing have made serverless popular. So they're limited in what they can do now, because then you can run small functions. There's a 5-minute limit on most of these commercial products and implicit limits on size. That is usually fine for an event-driven use case. If your smartphone generates an event, it doesn't usually take up to anywhere near 5 minutes to process it. Here's a quote of a related thing, that 2/3 of server workload will be deployed off premises, off your internal data center. And this is driven by the workload migration to public clouds and by new server investments by the hosting people and the public cloud service providers. So the number of workloads is going to double. This will not really show anything for on-premises. In fact, we showed in an earlier slide the expectation of a few percent per year decrease in the on-premises facilities per year, with a 19% increase of clouds per year. And then we have, I defined here hyperconvergence. I also did hyperscale for computing. Hyperconvergence is, again, largely a marketing term. It just says everything is converged, which is probably not a good idea. You want to keep everything nice and modular. And you have a single vendor, and that person supports everything. That's probably a bad idea. The whole purpose of the cloud is to have multiple vendors, a good mix of software, hopefully open source, and not go to integrated systems. Integrated systems have lots of problems. You really need to know what you're doing before you do that. And I say hyperconvergence is just a buzzword sold by people hyperconverging, by vendors who sell hyperconverging systems, which means they sell their own system, whether or not it's the best system. And so these integrated systems, of course, increase complexity and probably have the opposite impact from what people want. Here's a few more wise remarks about serverless computing. So obviously, it's huge advantage. You do not have to operate the infrastructure, and it allows developers. So this is all. They keep focusing on developers. You, the developer, will just spawn off your serverless computing, running inside some public or private cloud. So it supports horizontal scaling as long as the back-end resources are auto-scaling. And scalability is just a software design issue. So you don't have to actually worry about the infrastructure. Amazon will worry about it and provide the elasticity. And also, you only pay for what you do. You pay a little more per second, but as you only pay for the second you use, in general, as long as your job is sporadic, namely it doesn't run, if it runs flat out continuously, you shouldn't use functions as serverless computing because it's more efficient. It's cheaper to just buy by the hour. And this allows the serverless to use truly on-demand consumption. Currently, it's very lightly used. It's partly the immaturity of the technology, the 5-minute limit. And today, event-driven is not so common, and event-driven is central to serverless computing. We expect event-driven to grow in importance because it's a very natural technology. Everything from the edge is event-driven because something will arrive from the edge. Well, that better generate an event. And many things which are not done event-driven can be made event-driven. So when you launch your, when you do your workflow, you can make each step of that workflow be invoked by an event. You just don't do it today because it's sort of not necessary, but you can do it that way and then use this type of approach. Here we have a little bit on cloud native. There's a nice talk by Dennis Gannon about this at this link here. Here is a nice blog about cloud native. And the reason to do cloud native, it makes the best use of this cloud special features because clouds have traded off elasticity versus fault tolerance. So they're more likely to fail than a traditional HPC cluster, but they're much more flexible and elastic. Then the other feature of cloud native is microservices, containers, and functions, which has all these, which provides the modularity and to support scalable parallelism, rapid modification, and the ease of providing fault tolerance because you have these stateless functions running. And here's some examples of cloud-native applications: Netflix, Facebook, Twitter, Google Docs, Azure Cosmos DB, Azure Event Hub, Fontana, IoT Hub, AWS Kinesis. Okay, serverless. I mean, there's of course cloud native. So cloud native is uses DevOps. These are the things you need to put together. You use a continuous delivery software engineering approach. You use microservices if you want to make small functions, and that's what microservices are. And we use containers as they're lightweight and therefore suitable for packaging lots and lots of functions in. Whereas virtual machines would be a catastrophe. We'll have tiny functions and 10,000% more data, more bytes taken up by the operating system. So if you use cloud native and microservices, they will be self-managing infrastructure because of the automation of DevOps plus these. Cloud native is probably easier to make fault tolerant because it's event-driven and stateless. Then you can probably get hopefully better insight from these modular software approaches. Hopefully you build in security. Whether that's wishful thinking, I don't know. Certainly this is more efficient. Containers are lighter weight. Functional services allows close packing of all the functions in available core, idle cores, which the traditional, more monolithic, larger system is much harder to fit a large system in an idle core. Whereas you have thousands of small functions, you can fit those into idle cores. And teams have grown in size, and the applications have grown in size a factor of 10 over the last few years. And this microservices break large applications into smaller pieces, and they can be developed, tested, and managed independently. And so that is a good approach to software engineering.